of 2002. Solve. Z is equal to 1 by 2 p square plus q square plus p minus x into q minus y. So fxyz pq is equal to 1 by 2 p square plus q square plus p minus x into q minus y minus z is equal to 0. We find the derivatives, partial derivatives, and write in CHARPIT'S auxiliary equation. So fx is, from here we find q minus y into minus fy, from here minus p minus x, then fz is minus 1, fp is 2p upon 2 plus q minus y, fq q into p minus x. Now we put in the CHARPIT'S auxiliary equation. So dp upon fx plus pfz is equal to dq upon fy plus qfz is equal to dz upon minus p fp minus q fq is equal to dx upon minus fp is equal to dy upon minus fq. We put the values dp upon minus q plus y plus p into minus 1, so minus p is equal to dq upon fy is minus p plus x and q into minus 1, so minus q is equal to dz upon minus p into fp. Fp is p plus q minus y minus q into fq. Fq is into q p minus x. This will be q plus, so q plus, then so once we kept in the CHARPIT'S auxiliary equation, this is the form. And if we see, we can take this expression minus p minus q plus x, or we can take minus p minus q. So we take this or this, we can find out the values. So we get dp is equal to dx after cancellation. So integrating, we get p is equal to x plus a. A is arbitrary constant, and if we integrate from here these two equations, q and dy, dq and dy, these two, this one and this one, so this comes q is equal to, because denominator cancels out, y plus b. Now we put value of p and q in the given expression. So z is equal to 1 by 2 x plus a whole square, this is p square, plus q square is y plus b whole square, then plus p minus x. P minus x is a and q minus y is b, so ab, and ये प्रूव करना था. दिस इज द रिक्वायर्ड आंसर. ये एग्जाम्पल 2000 का है. सॉल्व बाय चारपिट्स मेथड. The PDE p square x x minus y plus 2pq xy plus q square y into y minus 1 minus 2pxz minus 2qyz plus z square is equal to 0. यहाँ पर एफ एक्स वाई जेड पी क्यू दिया गया, दिस इज इक्वल टू एफ एक्स वाई जेड पी क्यू. So we find partial derivatives and put in the CHARPIT'S equation. So fx is, because it's a lengthy expression, we need to be careful. This becomes x square minus x, so 2x minus 1. Then from here plus 2pqy, from here minus 2pz, that's it. Then fy is 2pqx plus q square, y square minus y gives 2y minus 1, then minus 2qz, that's it. Fz minus 2px minus 2qy plus 2z. Fp is 2px x minus 1 plus 2qxy minus 2xz. Fq 2pxy plus 2qy into y minus 1 minus 2yz. So we got the partial derivatives. Now we put in the CHARPIT'S auxiliary equation. So this comes dp upon fx plus p fz is equal to dq upon fy plus q fz is equal to dz upon minus p fp minus q fq is equal to dx upon minus fp is equal to dy upon minus f. So we put the values. So dp upon p square 2x minus 1 plus 2pqy minus 2pz plus pfz. Pfz means minus 2px minus 2qy plus 2z. So this is pqy. So this cancels out. This also cancels out. Minus 2p square x. It will also cancel out. So only thing is minus p square, which is dp upon minus p square. Now we find out dq upon fy 2pqx plus qy q square 2y minus 1 minus 2qz plus q into fz minus 2px minus 2qy plus 2z. So this is pqx q square 2y then 2qz. So this is dq upon minus q square. So we can integrate these two and can find the values. Though we will be able to integrate these two, but we will have a relationship between p and q, though we need p separately and q separately in terms of x, y, z. So we try to find out other values and we see that dx is minus fp is minus 2px x minus 1 plus 2qxy minus 2xz and dy minus fq. So minus fp means we have to change sign of each. So this is minus fq is minus 2pxy minus 2qy y minus 1 and plus 2yz, and we find out dz upon minus p fp and minus q fq. If we got dp as, we got dp upon minus p square is equal to dq upon minus q square. This we can rewrite. This is equal to 1 upon p dp upon minus p minus 1 upon q dq upon plus q, and this will be each fraction of the auxiliary equation. So these are equal to this. And we have found in terms of dx and dy also. So dx and dy we write in another form. 1 upon x dx we take like this. So this becomes minus 2px minus 1 minus 2qy plus 2z, and 1 upon y dy. So what we do, we bring it here minus, and we remove this. So minus 1 upon y dy, and in dy denominator is minus 2px, because minus, so it will become plus. Minus we have taken, so this will be plus 2px because minus we have taken, and next is minus is again plus 2qy minus 1 and minus 2z. So minus this cancels out, 2qy also cancels out, then this is 2px also cancels out, minus 2p and minus 2q are there. So 1 upon x dx minus 1 upon y dy upon plus 2p and minus 2q. And if we see this one, this expression, this is from the terms of dx and dy. So this was here, we can keep them equal. So 1 upon p dp, so we take minus sign to make it, this is 2p minus 2q, here minus p plus q. So we have to adjust one sign. So 1 upon q dq minus 1 upon p dp, and p minus q will cancel out, or q minus p is equal to 1 by 2 1 by x dx minus 1 by y dy, and denominator is cancelled out. Now we can integrate. Integrating, we get log q minus log p, and we add the coefficient of constant is equal to this is 1 by 2 1 by x dx minus 1 by 2 dy. So this becomes 1 by 2 log x minus log y. So we can say this is x upon y to the power half is equal to, we multiply aq upon p. Now we rewrite the given equation, and given equation is px plus qy minus z whole square. If we see this comes p square x square, then plus q square y square plus z square minus 2px z minus 2qyz plus 2pq xy. So the terms these are there, and in this equation it is px square minus, it is p square x square. So first term is there minus p square x, so we will have this extra minus p square x, then 2pq xy, 2pq xy, then q square y square, then minus q square y is extra, then 2pxz with minus and minus 2q plus z square. So we write it like this, and z square is here. So if we put them on this side, then they are equal. Or we can write px plus qy minus z is equal to under root of this, so plus minus p square x plus q square y to the power half. aq upon p is equal to x upon y to the power half, we have calculated earlier. So p is equal to aq upon x to the power half y to the power half. So from this we had obtained, so from previous expression we can write in place of p, it is px plus qy minus z is equal to plus minus p square x plus qy square to the power half. So what we do, we put value of p here, and it we got in the previous step px plus qy minus z is equal to plus minus p square x plus q square y to the power half. So we put value of p in this, so aq y to the power half and x to the power multiplied by x denominator, so remaining is x to the power half plus qy minus z is equal to, we take only positive side and it will be same here. Now we put in here also, this comes, we bring this on this side, z on this side, so minus, and this term we will write p square x. So p square is, x is first, then a square q square y upon x plus q square y and to the power half. Here this is same q common from these two, a y to the power half x to the power half plus y. So this cancels out, and from here we take q square y common, q square y common. So q a x y to the power half plus y minus y q square a square plus 1 to the power half is equal to z. So from here we can write q is equal to z upon y to the power half common. So this is ax to the power half plus y to the power half and minus a square plus 1. This is the value of q. Now this value of q we put in this p. So p is equal to a q is z upon y to the power half ax to the power half plus y to the power half minus a square plus 1 and into y to the power half x to the power half. So this will cancel out. So we put these values of p and q in dz, which is p dx plus q dy. So because terms are common, denominator this term is common, so we take this term as a x to the power half plus y to the power half minus a square plus 1. P is this, so p is az upon x to the power half dx plus q is z upon y to the power half dy. This is equal to dz. So we take z common from here and we remove from here and bring it here. So a upon x square plus 1 upon y to the power half dy, and here also we have this. So from here we can write down dz upon z and we take LCM in this. This term is same, ax to the power half plus y to the power half minus a square plus 1 to the power half, and LCM, because here it was left to the power half, so we have to take here. Now we take LCM, y to the power half a dx plus x to the power half dy upon xy to the power half. Now we integrate it. So in this what we do, we take this term as t. So dt is equal to a upon 2x to the power half dx plus dy upon 2y to the power half. Now we take LCM, so 2 dt is equal to xy to the power half into a, and in numerator ay to the power half dx plus y x to the power half dy. This term can be written as 2 dt. So we get log z is equal to 2 log t plus log b. So this is 2 log y to the power half plus ax to the power half plus a square minus 1 to the power half plus log b. So from here we can write down z is equal to b into y to the power half plus a x to the power half minus a square plus 1 to the power half, and because it was 2 log, so we will be taking square of this, where a and b are arbitrary constant, and this is the required answer. This example is of 1998. Use CHARPIT'S method to find the complete integral of 2x z square del z upon del y whole square plus 1 is equal to z del z upon del x. We take z dz is equal to capital DZ. It means when we integrate, we get z square is equal to 2z, capital Z. So now equation 1 which is given here will be 2x and this becomes del capital Z upon del y whole square plus 2x minus del capital Z upon del x is equal to 0. So now we can write 2x and we write capital P and capital Q because we are referring this z dz is equal to capital with reference small z dz is equal to capital dz. So this is 2x into q square plus 2x minus capital P is equal to 0, where this is P and this is Q. So now equation in the form of function, so we write capital P and capital Q is 2x q square plus 2x minus P is equal to 0. We write CHARPIT'S auxiliary equation, and this is dp upon dq. dp is equal to dq upon dz upon is equal to dx upon is equal to dy upon. So this is fx plus pfz, fy plus qfz minus pfp minus qfq minus fp minus fq. So fx is 2q square plus 2, fy is 0, fz is 0, fp this is capital P and this is capital Q. So wherever it is capital Q and capital P. So FP is -1 and FQ is 2x into 2q, 4xq. So we put in this dp upon 2q square plus 2 plus p, fz is 0, is equal to dq upon fy is 0, so this is 0, is equal to dz upon some value, because we have is even, these two can be used for integration. So dp into 0 is equal to 2q square plus 1 dq. So we have dq is equal to 0, so q is equal to constant. Q is equal to 8 means P, we have to find out P, we put in the question, and this is 2x a square plus 2x minus P is equal to 0. So P is equal to 2x a square plus 1. We put in dz, P dx plus q dy. It comes 2x a square plus 1 dx plus a dy. We integrate it. So z is equal to 2a square plus 1 x square by 2 plus ay plus another constant. Now we put values of capital P, capital Q and capital Z. So Z is z square by 2, small z square by 2 is equal to a square plus 1 into x square plus ay plus b. So this is the complete integration. We can multiply by 2, so z square is equal to 2 a square plus 1 x square plus 2 ay plus b. We put it b dash, so this is b, 2b dash is b. So this is the answer. CHARPIT'S method to find complete integral of px to the power 5 minus 4q square x square plus 6x square z minus 2 is equal to 0. So we have fxyz pq is equal to 0. We find out partial derivatives. Fx is 5 x to the power 4 minus 8 q square x plus 12 x is 12xz. Fy is 0. Fz is 6x square. Fp is x to the power 5 and Fq is minus 8q x square. So we put in the CHARPIT'S auxiliary equations. It comes dp upon fx plus pfz 5x to the power 4 minus 8q square x plus 12xz plus p fz is 6x square is equal to dq upon fy is 0 plus q into fz 6x square, then dz upon minus pfp minus q fq, this is equal to dz upon minus p x to the power 5 minus q minus minus plus 8q square x square, and it is equal to dx upon minus fp and dy upon minus fq means minus minus plus 8q x square. So we see which we can take. These two are easy to solve. So we take dq upon 6q x square is equal to dy upon 8q x square. This cancels out. So here 3, here 4. So 1 by 3 log q, 1 by 3 q, 1 by 3 q is equal to 1 by 4 y plus a. This is arbitrary constant. So 4q is equal to 3y plus 3a. 3y plus a upon 4 is equal to q. So we got q value. We can find out value of p. From first equation, from f, we can have p x to the power 5 minus 4 q square, that is 9 upon 4 square, so this square is gone, into y plus a whole square into x square plus 6x square z minus 2 is equal to 0. So p from here we can have p is equal to 2 minus 6x square z, then this is 9 upon 4 plus 9 upon 4 y plus a whole square x square upon x to the power 5. Now we put these values of p and q in dz. So dz is equal to p dx plus q dy, and this comes dz is equal to, from here we take 9 upon 4 y plus a square upon x cube minus 6 z upon x cube plus 2 upon x5 p dx plus q dy plus 3 by 4 y plus a dy. Now we take dz term on one side and rest of the term on one side. So dz plus 6z upon x cube dx is equal to rest of the thing. 6z upon x cube dx plus dz is equal to 9 upon 4 x cube y plus a whole square dx plus 3 by 4 y plus a dy plus 2 by x to the power 5 dx. So these are in terms of y decreasing, and this is constant in numerator. So we can see that this is the total differentiation of this equation is always possible. Total differentiable is always possible. So what we do, we find integrating factor of left hand side. So we think this is m dx plus n d z or dy form. but we have dx and dz. Generally we take mdx plus ndy. mdx plus ndz, m is 6z upon x cube and n is 1. So integrating factor is 1 upon n del m upon del z minus del n upon del x. ये आपको सब याद होने चाहिए कि कैसे हम इन्हें एग्जैक्ट इक्वेशन बना सकते हैं और इंटीग्रेटिंग फैक्टर फाइंड आउट कर सकते हैं. ऑल पॉसिबल केसेस, सो दिस इज वन ऑफ देम. इस एग्जैक्ट इक्वेशन के ऊपर ये जो हमें इंटीग्रेटिंग फैक्टर्स फाइंड आउट करना है रिड्यूसिबल टू दिस, इसके लिए एक सेपरेट वीडियो बना देंगे जिसमें कि सारे पॉसिबल केसेस दिए गए हैं. सो हेयर दिस इज इक्वल टू del m upon del z is 6x cube and rest is 1 1, so this is 6 upon x cube. So which is function of x alone? तो इसे हम इंटीग्रेटिंग फैक्टर निकालें. इंटीग्रेटिंग फैक्टर इज e to the power integral 6 upon x cube dx. This come e to the power minus 3 upon x square. So equation this we multiply by this factor on both sides. We get 6z upon x cube e to the power minus 3 upon x square dx plus e to the power minus 3 upon x square dz is equal to 9 upon 4 x cube into y plus a square into e to the power minus 3 upon x square dx plus 3 upon 4 y plus a into e to the power minus 3 upon x square dy plus 2 upon x to the power 5 e to the power minus 3 upon x square dx. See, left hand side is differentiation of z e to the power minus 3 upon x square. So if we take this as first function, this as second function, we can see we get this expression. Product of two functions is equal to, we simplify it in a form so it can be the differentiation of the function. So what we do, तो यहाँ पर हमारे पास y plus a square into e to the power minus 3 upon x square है. हम इसे differentiate करते हैं and according to that we write. So this comes 2y plus a e to the power minus 3 upon x square dy plus then this comes e to the power minus 3 upon x square and differentiation of minus 3 upon x square. So into minus 2 upon x cube into y plus a whole square. So we need these terms to have this. So what we do, we try to make them. So here it is 9 into minus 3 plus 6. So we need plus 6 and upon x cube. So here we have 9. So we take 3 common. 3 into 2. 3 into 2 will be 6. And in denominator we have 4. We multiply by 2. We make it 8. 3 by 8. And this is 6 upon x cube into e to the power minus 3 upon x square into y plus a whole square dx plus we have 2y plus a, so 2y plus a into e to the power minus 3 upon x square dy, and here we have 3 upon 4, so we took 2 here, and because we multiplied here also, so 3 upon 4 into 2. We take this also out, so this is 3 upon 8, we put another bracket, and this is the bracket. So now it's okay. This is differentiation of, and next term is 2 upon x to the power 5 e to the power minus 3 upon x square dx. So this is 3 upon 8 d of this we have already written, y plus a whole square e to the power minus 3 upon x square plus, now this is 2 of, here it will be integral of 1 upon x to the power 5 e to the power minus 3 upon x square dx. So when we integrate, this term will be as it is, we can find easily, but we have to integrate this term. So we remove from integrating, we remove this, and we have put this integration here. Okay, so now what happens, we integrate this term, we mark it a, and a is equal to 2 integral 1 upon x square, we break this into e to the power minus 3 upon x square into 1 by x cube d x cube. So here we assume minus 3 upon x square is equal to, say, t. So 6 upon x cube. So from here we can say 1 upon x square is equal to t upon minus 3. So 2 t upon minus 3 e to the power t, and 1 upon x cube dx is dt upon 6. So this becomes 3, and this is minus 1 upon 9 integral t e to the power dt. Now this can be written as z e to the power minus 3 upon x square is equal to 3 by 8 y plus a whole square into e to the power minus 3 upon x square minus 1 upon 9, and when we integrate t to the power t dt, this becomes first function and second function. First function integration of second minus differentiation of integration of second, so this comes t to the power t minus e to the power t. So this becomes e to the power t minus e to the power t plus constant, and t is equal to, we have assumed minus 3 x square. So we substitute, these terms will be same, and this comes minus 1 by 9 minus 3 upon x square e to the power minus 3 upon x square minus e to the power minus 3 upon x square, and this is the answer where a and b are constants. We can divide it by e to the power minus 3x square. So z is equal to 3 upon 8 y plus a square divided by e to the power minus 3 next a square plus, from here we get 1 by 3 x square, that's it, and from here plus 1 upon 9, only this much, plus b e to the power 3 upon x square, and this is the answer, complete integral. Thank you.